Hi everyone, this here is the Minimax sum problem by HackerRank. The link to this problem will be in the description. The problem says, given 5 positive integers, find the minimum and maximum values that can be calculated by summing exactly 4 of the 5 integers. Then print the respective minimum and maximum values as a single line or 2 space separated long integers. The constraints are that the array will always have 5 elements, and that the elements in the array will be 1 to anywhere from 1 to 10 to the power of 9. So let's go ahead and first reword this problem. So let's suppose this is our array that we're given, and in the array we have the elements 1, 2, 3, 4, and 5. If we calculate the sum of this array, we get 15. Now, the problem says that we need to find the minimum value that can be calculated by summing exactly 4 of the 5 integers. So if we do that literally, then what we would do is add 1 plus 2 plus 3 plus 4. Rather than doing that, we can take the sum of the array minus the largest integer, which would be 15 minus 5. And the same can be true for calculating the maximum value. Rather than summing 4 of the 5 integers, we take the sum of the array minus the smallest integer. All right, now that we know that, let's go ahead and look at an overview of the solution. So step 1, we calculate the sum of the array, and we find the biggest number, our max num, and we find our smallest number, our min num. So that's step 1. There's 3 parts to it. Step 2, we calculate the smallest sum, our min sum, which is the sum minus our max number. Then we calculate the biggest sum, which is our sum minus our min number. Lastly, we print the min sum and the max sum. So let's go ahead and do a sample problem. So given this array, we want to first find the maximum number, the minimum number, and the sum. So let's start with the first element, 7. Since there's no maximum number yet, since we're barely on our first element, 7 is going to be our maximum number, it's going to be our minimum number, and it's going to be our sum, because our sum, really it shouldn't say 0, or null, it should say 0. So we're going to do 7 plus 0. So now we have our max, min, and sum, and we move on to our next number, 69. So is 69 greater than 7? Yes. So that will be our new max num. But 69 is not less than 7, so 7 will still be our min num. And then we add 69 to 7, and we're left with 76. Now we move on to our number 2. So number 2 is not greater than 69, so it's not our max num. 2 is less than 7, so it is our min num. And then we add 2 to our sum, and we have 78. Then we go to our next number, 221. And we do the same thing for each element, right? Is it the max num? Yes. Is it the min num? No. But we add it to our sum. And then we check our final number. Is this the max num? Yes. Is this a min num? No. Now we add it to our sum. Great. So then we move on to our second step, calculating the min sum. So we're going to plug in our sum here and our max num. We calculate that, and we get 299. Then we calculate the max sum, plug in our numbers, calculate. Now we have 9,271. And our final step is to print the results, which we will do in our code. So go ahead, review these steps, pause the video, try to solve it on your own, and then we will solve it together. Now normally I would solve this in HackerRank where it says write your code here, but this window is kind of small and not resizable. So what I'll do is I'll solve it in my IDE and then copy and paste the solution into HackerRank. So the first step, we said we want our min num, our max num, and the sum. We need to calculate these three things. So I'm going to use long because it can store very large integers or whole numbers. And the min num, if we remember, it's going to start as the first element in our array. So we're going to get the first element. I'm going to do the same for our max num. And we're also going to do the same for our sum. Right? Because if we're looking at the very first element, then that will be the min num, that will be the max num, and that will be the sum. And if you can't remember why, go ahead and rewind back to our example problem. Okay, now that we have that set, we're going to go ahead and loop through our array. So we want I, which is our index, to equal 1, right? Because we've already assigned our 0 index. So now we're going to start at our 1 index, index 1. And we're going to say while our index is less than the size of the array. And we're going to say I++ so that we iterate through every element in our array. Okay, so let's get our current number of the array. Getting the element at index I. The first thing we'll do is we'll add the current number to our sum. Oops, sorry, not array sum. I'm going to say sum. Right, so we're adding the current number to our sum. Then the next thing we'll do is we're going to check, is this current number less than our min number? If it is, we have a new min num. Our new min num is our current num. We also want to check, is the current num greater than our max num? If it is, then we have a new max num. Our max num is our current num. Alright, so once we've gotten the min num, max num, and sum, we can move on to our second step, which is calculating the min sum and our max sum. So the min sum is going to be our sum minus our max num. And the max sum is going to be our sum minus our min num. Now that we have that, all that's left is to print the results. And the HackerRank problem said that we want to print the min sum first, have a space in between, and then print the max sum. Alright, so let's copy and paste this solution into HackerRank. Oops, sorry about that. Let me try copying again. There we go. So I've pasted the problem. I'll submit the code. And success. So I want you to pause the video, take a moment to try and figure out what is the time complexity and space complexity of this problem. If you're not sure what that is, I have a link in the description for big O notation, and that'll explain what time complexity and space complexity is. So looking at time complexity, as a review, time complexity asks, what's the relationship between our input and the time it takes to run our code? So if we look through our code, these 3 lines of code always get executed the same amount of times, regardless of what our input is. And the same is true for these lines of code. However, that is not true for this for loop. This for loop executes n number of times. It executes however large the array size is, right? So If our array size is n, which we don't know what n is whatever is given to us. We would say it executes 1, 2, 3, all the way up to n. So n is our time complexity, because the bigger the array, the longer it takes to run. It'll run n times. So our time complexity is O of n, where n is the size of the array. There is one caveat. So HackerRank has a constraint where the array size always equals 5. Now, if we know it always equals 5, then that means our runtime is constant. It'll always execute the same number of lines of code regardless of our input, because the input always has the same size. Next is space complexity. And space complexity, same thing. It's asking what's the relationship between this input and how much memory is being used in this method. So if we look, we have one variable here, so that's a space in memory. That's constant space, right? O of 1. We also have one usage here, another here, here as well, here as well. It's one space in memory. And anytime we make a call to a method, that method is added to the stack, which counts as a space in memory. And then we have this for loop. So everything right here, we've already created a space in memory for, so we don't need to write O of 1 again. We do say though that this I, right, that's our index, that's a space in memory. This current num, that is one space in memory. Even though we're creating multiple current numbers, one for every time we go through the loop. So let's just break this down. Say we go through the loop one time. We create the number, then at the end of the loop, we don't need that number anymore. So in reality, we could just say it's one space in memory, because it's created, then deleted, then created, then deleted. It might not be deleted immediately, but it's no longer needed for the method. So that would make our space complexity constant, O of 1. We use the same amounts of memory every time we execute our array. I hope this helped you guys. If you have any feedback, anything that helped, anything you didn't like, or just questions, please let me know in the comments. Thank you.